to record. So let's start today's session. Myself, Zahid Bashir. I am your trainer on quantitative primary data analysis. Today, we are going to discuss about AMOS. First of all, I need to discuss the basic aspects of AMOS in today's discussion. The advanced part will be discussed tomorrow. We will use the previously used data set of SPSS, like example final data set that I have used in my 11th or 12th session previously, or final data set that I used in my previous session, like in yesterday's session. And there is another data set that I will use. I will share all these three data set with you in your you can say the groups. So don't worry. First of all, I need to explain you the basics that are required to understand the AMOS, because in understanding the AMOS, you need to have some basic knowledge about the covariance analysis, which are the things that you need to apply over here. So today I will discuss these three things in today's session. What are the prerequisite for applying the SEM using AMOS? If you are a new person regarding the AMOS, and you are not sure how to use AMOS for structural equation modeling, then you need to have some basic understanding of the prerequisite which are needed to apply the SEM using AMOS. Then you need to understand the basic environment of AMOS, like screen layout and basic tools. Then I will apply a basic model, a basic measurement model for CFA, that is confirmatory factor analysis uh, using AMOS. So as I have previously mentioned that I was busy enough uh, in some of my tasks that I was unable to create the slides for today's session, but I was able to create the contents for today's session on Word file. So don't worry, I will cover all the aspects for today's session on my Word file. So let's start about what we will going to do about today's session. First, we need to understand the prerequisite. What are the prerequisite of understanding the SEM using the AMOS? So first, you need to understand the structural equation modeling. What is SEM? SEM is a statistical method used to analyze the relationship between observed and latent variable. In my previous sessions, two or three previous sessions regarding the smart PLS, I have delivered some sessions regarding the observed and latent variable. Observed variable is a variable which is already measured, which have some measurement, or you can say your indicators or your statements are your observed variable, because they are directly measured using 5-point Likert scale, 7-point Likert scale, or through some responses, you know. So the observed variables are those indicators which are directly measured, while the latent variables are the constructs that you measure through the observed variables. So these are indirect measurements. You can say your latent variables are the constructs which are measured from the observed variables. So it is a comprehensive approach that combines the aspects of factor analysis and multiple regression analysis. So you can say that SEM is basically the combination of these two things, factor analysis and multiple regression analysis, to examine the complex relationship in a model. So using a SEM model, you will also let you denote which independent variable will influence the dependent variable, and subsequently let dependent variable be independent variable in other relationship. So SEM is basically simultaneously analyzing the relationship between number of independent variable and number of dependent variable simultaneously. So this is how the SEM basically works. But there are two approaches that we use for analyzing the structural equation modeling. The one is the PLS-SEM and the second one is CB-SEM. So there are two approaches that we need to use, that need to use by applying SEM. So what are those approaches? The first one is PLS-SEM and the second one is CB-SEM. PLS-SEM is basically a non-parametric procedure which is applied using smart PLS that we have previously done. If your data set is non-parametric, if it has a number of observation less than 30 and there is no background theory in support of the analysis, then you are most probably going to use PLS-SEM. But if there is a theory behind, if your number of observation are greater than 30, then you are going to use the CB-SEM, which is covariance based structural equation modeling. So AMOS is about using the covariance based structural equation modeling. So what are the key components of SEM if we are going to use structural equation modeling? What are the key components that we are going to use? Uh, the first one is observed variables. These are the measurable variables, or you can simply call them indicators. They are indicators or the statements of your questionnaire that are measured directly, like using 5-point Likert scale or 7-point Likert scale. So these are called observed variables. Sometimes you have already calculated your variable through composite variable technique that I have explained in the starts of my sessions, like in session 1 or 2, how to calculate a composite variable. So if a variable is already calculated or measured, that variable is considered as a observed variable. So you need to understand when you have some values attached to your variables, it means it is observed variable. The second important component in a SEM analysis is latent variable, which means your constructs. These are also called the unobserved variables because they are not directly measured. They are measured through the observed variable or through indicators. So these are unobserved or underlying variables that are inferred from the observed variables. So you can say that your observed variable basically measure your latent variables or constructs. So constructs or factors that are not directly measurable frequently serve as a representation for a latent variable. Then there is a structural model, the model which is indicated through some path or through some relationship between your latent variable or your construct, is basically a structural model. So the structural model represent the relationship among the latent variable and how they contribute to the observed variable. It includes the hypothesized relationship and pathway between variables. So I have previously told you that when you create some path between your constructs or between your latent variable, it becomes a structural model. So this is how your structural model is indicated, and it is one of the most important component of your structural equation modeling. Then there is a measurement model which is used for measuring your latent variable, how your indicator basically measure your latent variable. This model represent the techniques. So this model defines the relationship between your latent variable and their corresponding observed variable, because every construct or every latent variable must be measured through some indicator or through some questionnaires. You need to have a measurement model first. So it helps to understand how well the observed variable measured the underlying constructs. Then there is a path diagram, which is basically the same as structural model. So whenever you create some path using some arrow keys, you are going to use a path diagram. So SEM is often depicted using a path diagram which visually represent the relationship between variable through arrows and path. This diagram helps to illustrate the directional influences and dependencies in the model. It will indicate which one of the construct is exogenous and which one of them is endogenous. The last important component of SEM is covariance structure. If you are using covariance based modeling, you are probably using the CB-SEM technique of SEM. And there is another technique which is known as PLS-SEM. If your data is not normal or it is non-parametric, uh, and there is no theory behind, you are going to use the PLS-SEM, which is variance based technique. So what are the benefits of using Amos for SEM? Because Amos is basically a software which basically aid the covariance based technique of SEM. It will not consider your data if your data is non-parametric, if it is not having normality, if the number of observation are too small, then your Amos would not consider it. Amos would be helpful if your data is normal, your data set has a number of observation greater than 30, 100, 350, 1000, 500, 700, and something like this. So you need to have a greater data set for applying the SEM. So what are the benefits of using Amos for SEM? Amos is basically the full form of Amos is analysis of movement structure. It is a specialized software tool designed for structural equation modeling, and it offers several specific features that make it particularly suitable for SEM analysis. So what are these features? The first feature is graphical user interface. You don't need to apply any type of programming. You can just use a graphical user interface in order to apply the SEM analysis using uh, uh, Amos, and it would be beneficial. It would provide you to create your path diagrams. It would provide you a lot of features in terms of model specification. It would provide you a number of options for estimation of your relationships, like one of the important method which is being used in Amos is maximum likelihood estimation as a default function which is being used in Amos. So researcher can choose from different estimation technique based on the nature of their data, such as robust method that are less sensitive to violation of normality assumptions. So if your data is normal, if your number of observation are greater than 30, then most probably you are going to use the maximum likelihood estimation. But there are a lot of options are available here. If your normality assumption is not going to fulfill, you are going to use such robust technique in order to fulfill the requirement of your data. But I would personally recommend, if your data is not normal, then you should use the smart PLS, especially PLS technique. Model fit indices, in comparison to smart PLS method, it would provide a detailed model fit indices. Like it would provide common fit indices, which includes the chi-square statistics, comparative fit indexes, Tucker-Lewis index, root mean square, error of approximation. There are a lot of indices or detailed indices that Amos is going to provide you for model fit indices as compared to smart PLS, because in smart PLS you are provided with one or two options to use as a model fit indices, but in case of Amos you are going to use a detailed model fit indices. Then model identification. This is another feature of model modification. If the initial model does not fit the data well, Amos allows for iterative model modification. This is just a feature. If your model is not fit with the data, it will provide some iterative model modification procedure that you can apply, and you will learn these things when I am going to use the AMOS using some data set. So researcher can make adjustment to the model by adding or removing path, covariances, constraints to improve the model fit. These are some of the things that you are going to learn during the process. Like you are going to add some path, you are going to remove some path, you can add some covariances, you are going to use some constraints to improve the fits. I will let you know how we are going to use covariances in our today's discussion. Then there is a bootstrapping method. Bootstrapping and Monte Carlo simulation procedure in AMOS that support the bootstrapping and Monte Carlo simulation, which can be used to check how stable model estimates are, get confidence interval, and see how stable the model is in different situations. So you can check the stability of your model using bootstrapping and Monte Carlo simulation. Our focus will be on bootstrapping. Monte Carlo simulation is basically used in some other domains. We are not basically concerned about Monte Carlo simulation. We are concerned with bootstrapping procedure that we are going to use in our SEM analysis. The next one is the integration with other software. AMOS is basically integrated with other softwares like SPSS. So if your data set is basically used in SPSS, that can also be used in AMOS. So we basically use SPSS data set in AMOS for importing our data set and for analyzing our data set. So you just need to use SPSS data set, which you have used previously in SPSS. You can use the same data set in AMOS. So AMOS basically applies covariance based approach. You need to understand what is covariance based approach before analyzing your data set in AMOS, because it is somewhat difficult and somewhat tricky as compared to smart PLS. In smart PLS, everything is basically user friendly. You just need to draw your path, you just need to draw your circles, constructs, your diagrams, and you can easily analyze your data. But in case you are going to use your structures, your constructs in case of AMOS, first you need to understand what is covariance based approach, because this is somewhat tricky where a lot of people could not understand with reference to AMOS. So AMOS is basically based on covariance based approach. So it is a fundamental aspects of structural equation modeling in general. When we are using AMOS, we need to understand covariance based approach. The covariance based approach is one of the two main approaches used in SEM. I have told you earlier that one approach is PLS SEM approach and the other one is CB SEM approach. So covariance based approach is basically CB SEM approach. Smart PLS basically have the feature to apply both of these approaches, like it would apply the PLS-SEM approach as well as CB-SEM approach. But in case of AMOS, we are able to apply only the CB-SEM approach, and we are unable to apply the smart PLS or PLS-SEM approach. So you need to understand that we are just going to use the covariance based SEM in case of AMOS. So in the covariance based SEM, the analysis is based on covariance matrix of observed variable. The model is estimated by minimizing the difference between observed covariance matrix and the covariance matrix predicted by the model. So you need to understand that the AMOS will automatically predict a covariance matrix, and it will compare the covariance matrix which is estimated by us using the Amos. So they will analyze and they will minimize the difference between observed covariance matrix and predicted covariance matrix. So maximum likelihood estimation is a common method used in covariance based SEM to estimate the parameter of the model. So in case we are going to use the covariance based SEM, we are basically going to use the maximum likelihood estimation. So here are some key points regarding the covariance based approach in Amos that you need to understand. First, you need to understand what is covariance based matrix or covariance matrix. Amos allows users to specify the relationship between latent and observed variables in terms of their covariances. The software then estimates the parameter of the model to best reproduce the observed covariances. So, what is covariances and how we calculate it, I will let you know after some of number of some pages. I will let you know in detail how you can calculate the covariances. But you need to understand the whole concept that what is covariance based approach in Amos. The second thing is maximum likelihood estimation, which is the default method in Amos for applying the covariance based SEM. So MLE is the default estimation method in Amos for covariance based SEM. This method aims to find the parameter values that maximize the likelihood of obtaining the observed sample covariance matrix. So it is a method which is used to find the parameter values that maximize the likelihood of obtaining the observed sample covariance. So through maximum likelihood estimation, we can obtain the observed sample to covariance matrix. Next is the fit indices. We have already discussed that Amos provides a greater number of different fit indices in detail, and we are going to use, and I will also explain today what is the criteria of using these fit indices, like how can we decide whether our model is fit enough to consider as a statistically significant model or not. So I will explain you what is the criteria for making decision about fit indices. Then covariance structural modeling. Amos supports the specification of complex covariance structure, allowing researcher to model intricate relationship between latent and observed variables. And last but not the least thing, that is theory testing. Using the covariance based approach, you can basically test a background theory, and it is a robust technique. It is a most robust technique for theory testing and assessing the structure of a specified model along with its relationship. So when you are going to use when you are going to test some theory based on the structure, based on the relationship that is provided in your model, you are basically going to use the covariance based approach. So this approach basically supports the theory testing. As I have previously told you that I will let you know what is variance, what is covariance, and what is the role of correlation in case of CBSEM or covariance-based SEM. You need to understand these points as a definition, as a initial concept, because in order to understand the complexity of CBSEM, you need to understand these points. So first of all, you need to understand what is by mean what is you mean by variance of a construct. The term variance describe how spread out the values, like responses or observation, are in a concept you are measuring. So when you are going to measure a construct using your responses in a questionnaire, you are going to see someone have choose strongly agree, someone has choose strongly disagree, someone has choose simply agree or disagree. So there are some variation between the responses or between the observations. So how much your data has variation or your responses has variation regarding the measurement of a constructs, that is the variance of a constructs. You can calculate this by finding the mean of all your observation and then taking the distance from the mean to record response observation and squaring that value. So this is basically a manual procedure. Uh, for the sake of your understanding, I am explaining over here that you just need to find out the mean of all your observation or all your responses that some of the respondents have might respondent to a questionnaire or to a statement using strongly agree, some of them have strongly disagree, some of them have used strongly agree. So you need to find the mean of all your observation, and then you take the distance from the mean to record the responses observation, and then you need to square that difference. Then in the next phase, what you need to do, you then take the average of all squared differences from the mean to get the variance. So this is basically the manual procedure. This is done, the software done it automatically. You don't need to worry about this procedure. I am just explaining for your understanding what is variance is. So this is usually a large number and has a little interpretation. But if you take the square root of this number, you get the standard deviation. So basically, what you do, you basically find the mean of all of your observation, then you subtract that mean from each response, and then you square the difference of that value, then you average all your square differences, and then as a last step you basically take the square root, and when you take the square root it will become the standard deviation of the mean. So this number is useful. Before taking the square root of this number, it would be a large number which has a little interpretation. But when you take the square root of that number, you get the standard deviation, and it is useful. The standard deviation is typically what is used to discuss the amount of dispersion or variation in trying to measure a concept. So you don't need to worry about these calculations because these are automatically calculated by the software itself. But you need to understand the basic concept that what is the variance is. So variance means the distance that you have found with reference to a single construct. So what is covariance between constructs? If you are taking the variance of two different constructs and you are measuring them all together, this becomes the covariance between constructs. In the previous concepts, we were discussing the variance of a single construct, that you are basically seeing that how values are different in a number of observations which are going to measure a single construct. But now we are dealing with the covariance between two different concepts, two different constructs. So covariance is the measure of how much two variable or two constructs change together. So it indicates the change between two constructs. If greater value of one variable correspond to greater value in another variable, you have a positive covariance. If a greater value in one variable correspond to lower value in another variable, you have a negative covariance. The main function of a covariance always is to determine directionality of two variables. So through the covariance, you will find out whether there is a positive direction, there is a negative direction between two constructs or not. So if the covariance is positive, then the two variable will move in the same direction. But if the covariance is negative, the two variable will move in the opposite direction. One might be upward, one might be going upward, and one might be going downward. But in case of positive covariance, they are moving towards the same direction. If one is moving the upward, the other will also be moving to the upward. If one is going to the downward, the other one will also be going to the downward. So this is the idea. This is the difference between positive covariance and negative covariance. One of the primary assumption in SEM is that the relationship between constructs follow a linear pattern. I have previously explained in detail what do we mean by linear pattern. It means uh, when there is a straight line which is basically depicted using two variables, or the relationship between two variables, there is a linear pattern or a straight line pattern, then an assumptions of the SEM is fulfilled over here. So put it another way, if you ran a scatter plot of the values of the two variables or two constructs, the data would be in line pattern that was increasing upward or decreasing downward. So you can find out through the scattered plot whether there is a linear pattern or not, and it will also indicate the covariance pattern of the relationship. So the function of a covariance always is simply to assess if the relationship between two variable is positive, thus having an increasing relationship, or a negative decreasing relationship. So you can see this graph, as I have previously mentioned, that if the relationship is positive or increasing, it will indicate this linear pattern. And if the relationship is negative, it will indicate this uh, linear pattern or decreasing or negative pattern. So what was the last thing here? While it is extremely unlikely that you will ever have to hand calculate a covariance value, it does provide us with a better understanding of the concept to see how the value is derived. So meeting is going to end within 1 minute, and I would request you to please join again using the same link, because there are a lot more that I will going to let you know, and I will also demonstrate the basic tools from the software itself. So please stay tuned and stay connected and join again using the same link, so that we